Okay, welcome to chapter 14 and 15, non-renewable minerals and energy. We'll begin 14.3. Remember, we're not doing the entire chapter 14. What are mineral resources and what are the environmental effects of using them? All right, so in your right side of your image, you've got mighty minerals over there. In your top left, we've got some people who are in a bucket brigade in the Dominican Republic, and this is how they extract minerals there in an undeveloped third world country, if you will. Now keep this picture in mind for when we contrast this with how we extract mineral resources here in the United States, Germany, and the developed world in general. All right, so some basic definitions. Minerals, naturally occurring material that can be extracted and processed affordably. Ore is the rock that contains large enough concentrations of a mineral to make extraction profitable, right, like aluminum ore, iron ore, etc. Reserves, published estimates of a given mineral supply that can be extracted profitably. So right now you can go online, you could Google the oil reserves of the world, and you could probably see the different OPEC nations, right, lined up from most proven reserves down to the least proven reserves of the 13 members. And then the depletion time is the time it takes to use up 80% of that mineral resource. Okay, so advantages of minerals, disadvantages. Go ahead and pause it, take a look at these. But what I want to draw your attention to and talk about briefly is this life cycle of a mineral resource. All right, so why certain things are hard to recycle or they become downcycled, and plastic is one of those things. Now it makes sense to recycle it because if not, it gets thrown into a dump and or it gets blown away and ends up in the Pacific Ocean garbage patch at some point. So from a collection standpoint, that is important. But for a metal resource, it is significantly less energy intensive to recycle a metal resource than it is to just get more ore, okay? Because we have to surface mine this mineral, we have to get this metal ore, transport it, then we have to separate the ore from this gangue, which is another term you'll learn a little bit, before we can then go and smelt it, and melt it down into something that can be transformed into a product, right? So if we can then take these used, discarded pieces of metal and bring them back to smelting, we can clip off these first 3 phases of this life cycle, which saves us tremendous quantities of energy. Because this last part right here actually uses very little energy. For example, if you take an aluminum can, right, and just throw it away and it's gone, that means to replace the aluminum can we have to get new ore and go through this part of the process. But if we take that aluminum can and bring it back to this part, we will save 95% of the energy required to produce a aluminum can from ore and from surface mining, okay? So we save 95% of the energy by bringing it back to this point if we're dealing with metal, right? So it's very important that we get in the habit of recycling all of our metals. And a little side note, one thing that is often thrown away that people don't ever think about is when you eat a Hershey Kiss or anything wrapped in aluminum foil. Because it's so thin and it has a little piece of paper in there, people just wrap it up and boom, throw it right into the trash can. That aluminum foil is recyclable. It's aluminum, it's metal. So go ahead, get in the habit of taking that and putting that in your recycling bin, okay? Don't waste it. It's your fun fact for the day. Okay, so types of mining. We've got surface mining and subsurface mining. So surface, we scoop ore off the surface of the earth or dig big holes and scoop it. The pros of surface mining is it's cheap, right? It's cheap just to dig into the earth. It's safe for the miners because you're not underground, there's no fear of collapse. However, some downsides, a large amount of environmental destruction, right? Because we are really destroying a large percentage or a large area of the surface of the earth, which can lead to things like runoff, erosion, etc. We have all this overburden that we have to remove. So overburden is, say we want to get to this coal right here, all this dirt on top, we're going to remove that. That's our overburden. All right, and then we discard it into these huge piles, this overburden. And once we make these huge piles, we call them spoils. Right, so now we've taken all this dirt, we've dug it up, made it very, very loose, made it into a huge mound. So what's going to happen when the winds come? What's going to happen when the rains come? There will be lots of what? Erosion. Good. What are the implications of this? It could end up, if there's a nearby stream, it could get into the stream, it would increase what? What's the word I'm looking for? A lot of sediment in the stream would increase turbidity. Well done. Well done. And those things are what we have to think about when we are answering FAQs about, mining and its implications. Subsurface is much more expensive because, of course, that tunneling, the reinforcement that goes into reinforcing those shafts, that all takes lots of money. It's hazardous for miners, of course, because there's fear of collapse, and not just collapse, but also when people are mining coal, a lot of times they'll get into an area where there's methane that's produced when these old materials, old living creatures, are decaying and breaking down to make this coal. They also make methane gas, and that can fill up the chamber. It can become explosive. It can also displace enough of the oxygen so that the people actually asphyxiate or suffocate and die. There is less environmental damage though, because usually you are leaving the surface of the surface of the earth untouched, so there is less of that erosion and runoff from it. Doesn't mean it doesn't happen, it's just less of it. And the red star means there's something else I had to tell you guys, but I remembered it. So in the United States of America, 90% of our non-fuel minerals, that would be things like aluminum, diamond, any of those things that we don't burn to create energy, 90% is obtained via surface mining. And 60% of our fuel resources, like coal, for example, are obtained through surface mining. Moving on. Types of surface mining. Open pits or mountaintop removal, right? And mountaintop removal, literally, they blow off the top of a mountain, right? So imagine like this big bowl that's filled with all the stuff you want, but there's a lid on top. And that's the top of the mountain. You just blow it off, and then you can scoop out all the goodies that you want. That's mountaintop removal. So the overlaying material is removed using large equipment, which creates huge pits. Imagine this is that big bowl, right? And they've got this road that goes around and spirals down, and here are the little teeny tiny cars at the very bottom of this mine, which looks like to me to be some type of coal mine. Creates pits that are hundreds of meters wide and hundreds of meters deep. Strip mining. So in strip mining right here, it's very similar to what we just looked at, except instead of going deep, usually you just spread out in a large area. So the material that you might be after may not be very deep into the Earth's crust, right? Maybe only 20 meters instead of hundreds of meters or thousands of meters. So you would stay roughly near the surface of the Earth, but it's spread out over a larger period. And then, of course, just like when we did food, we had a very hilly area, we would do contour planting, right, where we would make our rows of crops perpendicular to the slope, right, and kind of follow a little bit of that nice contour, right, so it can catch some of the runoff. So we have contour mining as well, where we will mine in those strips, which is slightly better than this, but, you know, any type of surface mine, there's going to be environmental implications. But not mining also has economic implications, so it's got to be a catch-22, right? There's got to be give and take. It's a catch-22. Now, thinking back to the people in the Dominican Republic who had the bucket brigade, this is how we do things in the developed world. Look at this scooper. Large bucket wheel extractor being moved through Germany, moves 10 meters per minute on this road. Takes 5 people to operate when in operation in a coal mine, and is used in strip mining. So we use these here in the United States as well. That's incredible. It's a little bit faster than 12 people in a bucket brigade. So crazy. All right, subsurface mining. So we've got these guys out there, down there, digging these mine shafts, where they have blast chambers, what else, and they transport deposits to the surface. And this is how it works. They will dig these tunnels, right? Where this is supposed to be a tractor, and they have it here in this part of the mine shaft. What they'll do from the top is they dig. This is the stuff that they want to harvest. They want to get this material. They want to get this material. So they have dug with drills these vertical mine shafts right here, right? It's vertical shafts. Then they put explosives in there. Right, now since these are drilled so close together, right, they're fragile. They'll break easy. So when they put the explosion, all this stuff will fall down. All this stuff will fall down, and then these scoopers can come in, pick it up, and then drive it back up these shafts to the top. Okay. In tropical forests, gold mining is accomplished by hydrologic mining. Okay, hydrologic mining. And if you guys have ever seen those Discovery Channel shows where they have people up in Alaska, they do a very similar thing where they just use water from a stream. They blast the slopes of a hill, and that blasting just causes land subsidence, right? Where it slides down and then just goes into some area where they've got a machine that's shaking it back and forth to remove the larger rocks from the smaller pieces. The larger rocks from the gold pieces, and they just keep moving it through until they can extract the gold. So that is hydraulic mining. Okay, so dredging. We've got, I think it comes on later on where it talks about the hydrothermal vents, so I'll save that. But one thing I want to say here is, if you have time, look up on Google Dubai and look at the islands that they are making in Dubai. They've done the Palm Islands, and this is them actually making the World Islands that they just finished 5-6 years ago. And what they do is they go up and they, with these big tankers, they have a tube that's sucking sand off the bottom of the ocean, and they're blasting into these huge piles that literally create new islands. Okay, so it's a type of dredging. So they're removing sand from the bottom of the ocean. We do it here in Florida at a very high cost to re-nourish our beaches, and we do it because tourism depends on these beaches and generates a lot of money. So there's economic purpose behind it. The downside, however, is that if you remember what is the name, the scientific name that we learned for the coastline? The blank zone? The neritic zone. Well done. It's part of the coastal zone, the neritic zone. And it represents what percent of the overall ocean? 10%. And in that 10% of the ocean, what percent of marine life spend all or part of their life in that neritic zone? 90%. You guys are so smart. I'm so proud of you. So 90% of the world's ocean organisms spend all or part of their life in this 10% of the ocean, which happens to be the coastline. So you can understand why dredging and destroying this fragile ecosystem can have big implications, right, in the long run. Health problems. We need to be familiar with them, but they're very easy because of their names, right? So obviously a mine could collapse. A fire can take place due to the methane inside of a natural gas, when they're looking for natural gas when they're harvesting coal. Causes asphyxiation, right, which is lack of oxygen, because the methane and the carbon dioxide will get in there, carbon monoxide, sorry, and that will bind to your hemoglobin. Carbon monoxide binds to your hemoglobin better than oxygen. The hemoglobin has a greater affinity for this than oxygen, so that will suffocate you. And then methane, right, if it displaces the oxygen, then there's no oxygen for you to breathe. Pneumocinosis is from inhaling coal dust. All right, so just tie this one to coal dust. Asbestosis, easy to tie that to in your mind to asbestos because it sounds just like the substance it's describing. Just like silicosis is from silicate dust, right? Silicate dust is from processing sand. Heavy metal poisoning from mercury is always a good example, which most of the mercury that we are suffering from, a large percentage, comes from the burning of coal, which often has small amounts of mercury in it, but burning it at great quantities puts it into the atmosphere. Then it rains down back to us and gets into our waterways, which is how it gets into our fish, and we eat the fish, you get the point. And then radiation exposure in uranium mining. So the problem with things like silicosis, asbestosis, and pneumocinosis is that all these things get into your lungs. They make cuts as they're breathing in. It gets in there. It doesn't come back out once it's in. It creates scar tissue, can exacerbate asthma, cause emphysema, and worst of all, can cause cancer, lung cancer later on in these people's lives. Environmental damage from mining, disruption of groundwater flow patterns. I think about that when I watch the hydraulic mining in Alaska, where they're blasting, using the river water to blast the banks of the river to get the gold. Obviously, they're destroying that ecosystem there. Loss of topsoil in strip mine regions. Topsoil, on average, takes 250 years to form from the decay of plant material. So when we strip out these areas in these mining practices, we lose that topsoil forever. Gangue is another vocab word. So once we take the ore and we separate the thing that we want out of it, like maybe it's aluminum, that leftover crap that we don't want from that ore is called the gangue. Tailings is specific to the gangue, right? So when we pile up all of that, the gangue, that's called tailings. So I know you're thinking, well, there's so many of these words and they're so familiar, right? Like spoils. Spoils are the big piles of overburden. Tailings are the big piles of gangue. Does that make sense? And since gangue comes from the ore, usually gangue and tailings are specific to metal mining, okay? And spoils are more specific to fuel mining, like coal, okay? Spoil banks, these big piles of overburden can be weathered away, eroded away, end up in the rivers. Oftentimes they contain toxic materials, and I hate that word toxic because it's vague, so we're going to get more specific here in just a minute. They cause sediment runoff into the waterways, nearby waterways. Sediments create turbidity, which decreases photosynthesis, which can then decrease dissolved oxygen, which can then cause fish kills, which can then create dead zones. Steep slopes are slow to revegetate, so after we strip this stuff off and remove that topsoil, it's kind of taking it back to primary succession, right? Because secondary succession happens when there's still enough life there and soil for things to pick up where they left off. But if we remove all of that topsoil, it's like taking it back to a new volcanic island where that topsoil has to be completely regenerated. And subsidence of land. Okay, so here's some mine tailings. Look at that big pile. So they're using the word tailings, which means that this is a pile of gangue, which means they're probably doing metal mining here, right? And I believe this mine actually is gold, if I'm not mistaken. And this, obviously just piled up there, is very easily eroded away. Contamination, there it is. This is where you get more specific. This toxicity I was talking about, right? Heavy metals. So arsenic, mercury, these are both naturally occurring. However, if we're mining mercury and we have these tailings that are left over, they very easily get eroded away into our water. Arsenic sometimes is used in a compound that they use to dissolve gold and then try and extract the gold out of this arsenic, and then they have these holding ponds of this material. Sulfuric acid, contamination from sulfuric acid produced through weathering of iron sulfide pyrite in tailings. So when we mine iron, there's always some that is left over in the tailings, right? We're not going to get 100% of it. That reacts with the water in the presence of oxygen to create sulfuric acid, and then when it gets into our waters, you'll see what it looks like in a second. These next slides show it, but obviously it creates, the waters become acidic, which causes fish kills, and it dyes them red. So water leaking into mine shafts washes dissolved metals and toxic materials into our water sources. Right now there are 500,000 abandoned mines in the U.S., 12,000 miles of rivers and streams contaminated with mine drainage, and the cost to clean it up is estimated to be $72 billion. Here are what these acid mine drainage systems look like. So you see how it turns the color red, looks kind of like Kool-Aid. Impact of mine drainage on a lake after receiving effluent from abandoned tailings impoundment for over 50 years. And this one is coloring orange and more red from the tailings. And that's the end of that one. That was a long one. I'm sorry about that.